5 quick properties of normal distribution, and then I'm going to explain to you what's called empirical rule, which is really super easy to learn. So first property of normal distributions is the curve is bell-shaped. Hopefully you've heard of that before. If you have a normal distribution, you have this curve where it's shaped like a bell. And I think we've talked about that way back in like chapter 2 or something like that, okay? Second property is that the mean, the mode, and the median are all equal, and they're located in the center, or located at the center. Oops. Okay, the curve is bell-shaped. Your mean, your mode, your median are all smack dab in the center of that curve. Third thing, the curve is symmetric about the mean. What does that mean? Again, that means half your data is on one side, half your data is on the other side. Everything is symmetrical, looks the same. To be considered normally distributed, that's what you would have as equal amount on the left as you would on the right when the mean is in the middle. So it's symmetric. Bell-shaped curve, mean, mode, median are equal, and the curve is symmetric. Fourth thing, the curve is continuous and never touches the x-axis. This is where statistics can get a little bit more theory, but what happens is the curve, you'll see the way I draw it, I never actually make the ends touch the x-axis. They do keep going. So it's continuous, symmetric. Mean, mode, and median are equal. The curve is bell-shaped. These are all the most important things that you need to know. And then the last and final thing, and then I'll draw it for you. The last thing is that the total under the curve is 1 or 100%. The total under the curve is 1 or 100%. So this is your bell-shaped curve, something like that. And what you have right smack dab here in the middle is good old mean. We're going to call it mu. Your mean here, your mode is here, your median, everything is right smack dab in the middle. Now, I can go one step over and I would be at what's called mu plus 1, and then that little symbol right there, anybody remember what that means? I know it's been a while. Standard deviation. If I go one standard deviation past the mean, I would be located here to the right. If I go one standard deviation to the left, I would be whatever my mean is minus 1 standard deviation. I could go 2 standard deviations to the right. I could go 2 standard deviations to the left because, again, everything is symmetrical. And then I could go 3 standard deviations to the right. Anything past 3, right or left, is really almost insignificant. It's so far beyond our mean. But that will come into play into future things that we look into. Now, I'm going to teach you something called the empirical rule today, and I think it's going to hopefully make a lot of sense. Here's what the empirical rule says. It says that from the first standard deviation right and left is 68% of your data. 68% of your data is within 1 standard deviation of the mean. Again, this is only if it's normally distributed. If it's not normally distributed, then we got a problem. But normally distributed, if I'm looking at my grades and all my grades are like, I've got, one F, one A, I've got 2 Ds, 2 Bs, and it's all nice and normally distributed, then 68% of my data would be within 1 standard deviation of the mean. Within 2 standard deviations of the mean, you're at what's called 95% of your data is within 2 standard deviations of the mean. 95% of your data is within 2 standard deviations. If you go to 3 standard deviations, you are not fully at 100, just so you know. You're actually at 99.7%. You have covered 99.7% of your data by just being 3 standard deviations in the mean. This is known as the empirical rule. Some books actually call it the 68, 95, 99.7 rule. That's another title that they give it, the empirical rule. I know, right? Very brilliant of them. Now, I want you to draw these 3 graphs. They're going to help you with your homework tonight. And then I'll give you your worksheet and we're done. I mean, this is really quite simple, and hopefully you understood it. But I wish that my stats teacher had done this for me, but they never did. And I'm like, this makes so much more sense. You'll see it's going to be like, oh, yeah, that's really easy. So we're going to call this graph 1. I want you to draw your little curve again. And I want you to put mu and then put +1 and -1. Okay, so now, if I asked you what percent of the data is from here to here, what would you tell me according to what we just wrote? Within 1 standard deviation, what would you say? 68%, okay. Then how much would be from here to here? Logically, what are you doing? Dividing in half. So 34 here, 34 here. Does that make sense? Okay. Then how much is left of the data from here and here? And tell me how you figured that out. How much would be left here to here? Let's go over this. How much should be under everything? We just said. No, under everything. 100%. Because remember, it doesn't, yes, all the way to 3rd would be 99.7, but all the way is 100%. What's 100 from 60? What's 68 from 100? 32. So what would this piece and this piece then be? 16, thank you, yes. 16%, 16%. This will come into play. You'll see why in a minute. So write that one down. Actually, the 3rd graph is probably the one that makes more sense. Okay, let's do what I call graph 2. Draw your curve again. Dot, 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 dot. Put mu. Put 1 standard deviation, put 2 standard deviations. So +1, +2. Put -1, -2. Okay. We have already established from the above graph that from here to here is 34. Would you agree? 34%? And from here to here is 34% because that's 68% of your graph. What would then this piece and this piece be, and how would I figure it out? Well, 2 standard deviations away from the mean was how much on your other graph? 95. If I've used up 34 and 34, that is 68, yes? So 95 minus 68 would be what? Anybody know or have a calculator and tell me what's left? 27. So then how do I figure out this piece and this piece? Divide that by 2. This is 13.5%, and this is 13.5% of your data. 13.5 plus 34 plus 34 plus 13.5. I mean, add it up. It makes 95. So then question, how much is left from here and here? Anybody? 5% for both, correct? So then how much for this piece and this piece? 2.5. Good job. That's how you figure it out. Now, I mean, mind you, my teacher never let me do that. So I was like, what? Now, graph 3 is going to probably be the one that you're going to use the most on tonight, because we're going to go all the way, fill in all this chart, and it's going to hopefully, boom, make complete sense. What I want you to do is I want you to write mu plus 1 plus 2, and then go to plus 3. Obviously, you leave a little space, and then do the same thing right here. Minus 1, standard deviation, minus 2, and minus 3. And now again, using the graph 2 above it and graph 1 above it, we're going to actually fill in every single one of these pieces. And this is all you'll have to do tonight. It's pretty much just adding. It's literally adding the pieces together. So how much is in this section and this section again? 34. 34. How much is in this section and this section, where my fingers are? 13.5. 13.5. We need to figure out the rest now, and I'm going to show you how to mathematically figure this out, okay? Because it's not hard. It goes to the next line. At 3 standard deviations away, you have covered 99.7% of your data, correct? 99.7%. How much do I have right now with just those 4 columns? 95. So how much is left for these two to be? 2 point. Give me my thing. 95 minus 99.7 minus 95. It's 4.7. Cut that in half for me, because we need one on this side and one on this side, and it would be, I'll just give it to you, it's 2.35% would go here, 2.35% would go here. If you add all of these together, these 1, 2, 3, 4, 5, 6 boxes, you would get 99.7. Would you agree? And if you don't, just say, Okay. Now, how do I figure out what's here and what's here? Well, how much do I have left after 99.7? 0.3% for both of these. Cut 0.3 in half. 0.15%. 0.15%, which is what this is. 0.15%. 0.15%. Now, if you add up all those numbers, you would have 100% of your data. And I'm going to show you how we are going to answer some questions about this right now, which is part of your homework.
It's like slightly over
Okay, I'm gonna do example 1, example 2. Your job will be just to finish the back of this sheet where it says Empirical Rule 1. That's your homework for tonight. It's actually quite easy. I would suggest you draw this because drawing is actually helpful. Example 1 says on the front, you've been given that the scores of a test are normally distributed, and that the mean score is 80 and the standard deviation is 7, okay? So watch, the mean score would go right here in the middle, 80. The standard deviation is 7, so what would I write for one standard deviation past that? 87. What would be 2 standard deviations past it? 94, does that make sense? What am I doing, by the way? Just adding what? Just adding 7. 3 standard deviations, 101. Go the other way. Take away 7 from 80. Where would you be at? 73. Take away 7 from 73. 60 what, 6? 66. Take away 7 from 66, 59. So these are the grades on a test within one standard deviation. The mean of everybody's test, let's say in statistics, was 80. One standard deviation away, some of you were 87, some of you were 73, et cetera, et cetera. Now, the question number 1 says, what percent scored less than 87? Okay, so less than 87 would be, here's 87, would be to the right or to the left? Everybody to the left of that. Would you agree? Okay. How much was this block right here? We just did it on the other graph. 34. How much was this block? How much was that block? You're going to have this memorized, so don't worry. 13.5. How much was this block?
2.35.
How much was this block? Guess what you're going to do with those precious numbers? That's it.
Or you can just add up the ones to the right and subtract them from 100.
Exactly. That's another way of doing it.
Wait,
Just to add the small number together. Easier.
I have 84, but what did you just say it was?
84.1.
I've had 84. Because I used the 6816.
It should still work. I mean, whatever.
Thank you.
Okay. So then what percent scored less than 73? Do that one. Go to 73
16.
and go less than, which would be left.
Yeah.
I thought it was 16.
16.
Yeah, because it's still 68.
Mm-hmm.
16
All right. You figure out now what scored more than 94%.
I didn't look at
Go to that block. Go to all the blocks above 94. Here's 94. You're going more than 94. More than 94. So here's 94. More than would be this block and this block that way. So 2.35, right? And 0.15. What do those two add together?
2.5.
Does this make sense? This shouldn't be hard. All right. Read number 4 now. Number 4 is backwards a little bit, just backwards thinking. 2.5% scored less than what value? 2.5%. Where's my 2.5% located? It's either from 94 and above, right? We just did that. But scored less than would be, wouldn't it be on this side? It'd be below 66, right? Scored less than 66. All right, and then the last thing, give the interval for the 99.7%. What would be interval? And the way you write interval is you write parenthesis, comma, between what and what and scored 99.7. 99.7 is the third to the third. 59 to 101. All right, I want you to try that same one for example 2. I want you to try that same thinking. You've got to draw it. Put your mean, put your 1 standard deviation to the right, put your 1 standard deviation to the left, and add up the percentages. A lot, but you could totally get it done. What percent took longer than 29? Here's 29. Wouldn't you agree longer goes that way? What would you say?
2.5.
2.5, because you would add the 2.35 here and the 0.15. I mean, that's what you could do right now. You could just put all those numbers in. 13.5, 34, 34, 13.5, 2.35, 0.15. What percent took less than 29? So you would take 29 and go all the way that way, which would be 97.5. What percent took between 13 and 29? So you add up 13.4, 34, 34, 13.5, which is 95. What took between 13 and 25? What'd you get for that one? 81.5. Add up this guy, that guy. What percent took longer than 17? These are important words. Would longer go to the right or would longer go to the left? To the right. So you add 34, 34, 13.5, 2.34, 0.15, and you should get up 84. Last but not least, what percent took less than 13? 2.5. This is what you'll be doing tonight. You do exactly the same thing for each one of these. Get a little chart and you should be fine. Okay? Welcome back. Welcome back. We still got till, we got 5 minutes.
Do we go to chapel right after?
Yeah.
Oh, I thought we go to
10 o'clock.
church.
10 o'clock, you go to chapel.
Yeah, we get up early, so I did.
I'm a little confused myself, but.
We got a Thursday after chapel.